All right, on to some more review. Let's see what we got here. Okay, so the position function of a particle moving horizontally along the x-axis is that. So we want to find the velocity function, and then let me go ahead and I will just read this off of my book so that you don't have to keep erasing. Okay, so let's find this one. Okay, so there's our position function, and we want to find the velocity function. Okay, let's see, there we go. We'll just go ahead and do a little nice white page. Okay, so our position function is 2t cubed minus 3t squared plus 2. So our velocity function is just going to be the derivative. Remember, position is the first function, then velocity is the derivative, and then acceleration is the derivative of that. Okay, so our velocity of t, this is really important that you label it like that so that I know that you're talking about the velocity function, right? We can't just write equals and then just put an equal sign, right? So we want to put velocity function equals 6t squared minus 6t, and then the derivative of 2 is nothing. So that is our velocity function. And then find the acceleration function. Well, remember the acceleration function is just the second derivative, so we're going to derive it one more time. So we have 12t minus 6 is our acceleration function. And when is the particle at rest? Okay, so think about this, what it means, okay? So some people are big memorizers, and they can just like say, okay, when it's at rest, that is always such and such, right? You can just like memorize it. And other people have to reason through it. So either way that works for you, but remember that at rest means that it is not moving. It has no speed, okay? That means the velocity has to be 0, right? Because velocity tells us how fast it's moving. And if it's not moving, its velocity is 0. Okay, so when is it at rest? That would be when the velocity is equal to 0. Now, that doesn't mean when time equals 0, right? So we're not going to put 0 in for time. We're going to say the velocity, which is v of t, is going to be equal to 0. Okay, so this over here, the velocity is equal to 0, and then we solve. Okay, so we say velocity equals 0, 6t squared minus 6t, and we solve this. We can bring a 6t out. And inside we have a t minus 1, and that equals 0. So when t equals 0, right, because remember, either when this factor is equal to 0 or when this factor is equal to 0, the whole thing is equal to 0. So when t equals 0 and when t equals 1, our particle is at rest. Okay? The next question is, when is the particle moving left? And this is one of those things you just have to think about again. So velocity has direction and magnitude. Makes me laugh every time. Okay, has direction and magnitude. So the direction of the velocity is told to us by its sign. Okay, if the sign is positive, it's moving right. If the sign is negative, it's moving left. Okay, so we just take the velocity and figure out if it's positive or negative at that point. So when is the particle moving left? Oh, so we have to figure out when, right? So it doesn't say at such and such time. So how do we know that? Well, we know that the particle rests at 0 and at 1. Therefore, it is moving before and in the middle and after. Okay? So we know that it probably changes direction, or it could change direction at each of these points, because it has to equal 0 for it to change direction, right? So if it's moving left, moving left, moving left, and then all of a sudden it starts moving right, at some point, even for an instant, it has to be 0, right? It has to stop and start moving right. It can't just, like the velocity can't keep going, right? So what we do when we're checking for direction is we think about, okay, let's find the points where it's at rest. Let's find those 2 zeros. And then we'll check and see if it was moving left or right before it stopped, left or right in the middle, and left or right on the other side. So like this. So we know at 0 and at 1 it changed, or it stopped, okay? So let's figure out before 0 And I know you just love negative time. But before time equals 0, let's plug that in and see what happens, okay? So we plug that into our velocity function. So let's plug -1 into it. Then we plug -1 into this, we get 6 plus 6, which is a positive number. Okay, so it's positive here. And when we plug in like 1/2 to this, we get 6/4 minus 3. So 6/4 is 3/2 minus 3. That's a negative number. So in between 0 and 1, it's negative, so it's moving left. And then above that, if we plug in, say, 2, we get 24 minus 12, which is a positive number. So we know it's positive there. So moving left would be when it's negative. So we know it's moving left when x is in between 0 and 1. That's when it's moving left. Okay? When is the particle's velocity equal to 12 feet per second? Well, this just said set the velocity equal to 0 and solve for 12. Or set the velocity equal to 12, not equal to 0, and solve. Okay, so when is the velocity equal to 12? Well, let's divide by 6. And we get 2 equals t squared minus t. And then we subtract 2 from both sides, so we have 0 equals, oh, you probably can't see that because my face is in the way. Sorry about that. 0 equals t squared minus t minus 2. And then we're going to go ahead and factor that out. So anytime you have something equal to 0, obviously, like, you just want to factor it, okay? You want to factor it because then you could set each factor equal to 0. And this might be something that I know you learned in algebra, but it's been a long time. So that's how you do it. When you have it equal to 0, you factor it, okay? So we have t minus 2 and t minus 1 because those have to be, t plus 1, excuse me. Yeah, I double checked myself because I was like, let me make sure. No, that would multiply to -2, add to -1. So at t equals 2 or t equals -1, our velocity is equal to 12 feet per second. And F says, find the particle's speed when the acceleration is equal to 0. Okay, so first we have to find when the acceleration is equal to 0. We have to figure out what time that is. Then we have to plug that time into our acceleration function. So the acceleration function, oh, I have it up here. It is 12t minus 6. This is why it's really good. I mean, it's good to label your stuff because you have to, because you get points taken off. But it's really good to label your stuff also because then when you need it again, we can just go back here. Yep, 12t minus 6. All right, so when is our acceleration equal to 0? Well, so we set this equal to 0. And we say 12t minus 6. So that is when 12t equals 6. And at time 1/2, the acceleration is equal to 0. So then we just plug that back in to our velocity function. Okay. Now again, our velocity function is up here, 6t squared minus 6t. So velocity of 1/2 equals 6 times 1/2 squared minus 6 times 1/2. Okay. And then, excuse me. Okay. So 1/2 squared, again, is 1/4. So we have 6/4. Minus 3, which is 3/2 minus 3, which gives us -3/2. Okay, now here's the thing. We know that this means it's moving in the left direction because it's negative, but it asks us for our speed. Speed does not have direction, okay? Speed just tells us how fast we're moving. It doesn't matter if we're going north, south, east, west, left, right. It doesn't matter. It's just how fast we're moving. So we always take the absolute value of our velocity to get our speed. So our speed at time equals 1/2 is 3/2. And we do have units, so it's going to be feet per second. Okay, and the last one, oh no, two more. Okay, the displacement, particles displacement. So from t equals -1 to t equals 3. So displacement, remember, has to do with where it is. So where it is the position function, okay? So our position function is the very first function we got, which is x of t equals 2t cubed minus 3t squared plus 2. And it says, how far did we change from when t equals -1 to t equals 3? So we're going to go x of -1 and figure out what that is, and then x of 3 and figure out what that is, and we're going to figure out the difference between the two. Okay, so -1, that would be -2 minus 3 plus 2. So that is -3. And then x of 3 would be 3 cubed, which is 27, times 2, you're really stretching my brains here, which is 54, minus 3 times 9, which is 27, plus 2. And then 54 minus 27 is 27, because 27 times 2 is 54. And then plus 2 should be 29. All right, so, oh, darn, you know what? Oh, yeah, no, we are. Whew. I thought for a minute I was doing the wrong problem. Okay, displacement is final, like, position minus initial position, right? So it's like, it doesn't matter how many times I went back and forth to my house. If I talk about displacement right now, here I am at school. If I went home, I'm really like 8 miles away from my household. So my displacement is 8 miles. We're not talking about distance, okay? So displacement would just be 29 minus 3, which is 26 feet. Okay, so this is 26 feet away from where it started. That's not right. So what did I do wrong? Oh, I know. The -3. The -3. Of course, you take the final, I even said this, the final minus the initial, okay? So this is 29 plus 3. And the way you can think about that is you think about a number line. How far away is 29 from -3 on the number line? It is not 26. It's 32 away from each other on a number line. So you have to make sure you pay attention to that. Okay, now this is the one that I thought I was supposed to be doing. I am supposed to be doing now. What is the total distance traveled? Okay, so we come back up here and we see that it changes direction at 0 and 1. Okay, so we're going to remember that. At 0 and 1, it changes direction. So I'm going to redraw that for us right here. Okay, at 0 and 1, it changes direction. So I'm going to figure out its displacement, or the distance in between -1 and 0, and the distance between 0 and 1, and then the distance between 1 and 3, because that is between -1 and 0, it's always going in the same direction, so that's going to tell me its distance, and then between 0 and 1, it's always going in the same direction, okay? So, f, or actually we should say x, because that's our function, x of -1 we found was -3, and then x of 0 would be equal to 2. Okay, so how far did it travel during this portion? It traveled 5. Okay, and then x of 1, so it was traveling, I believe we figured out it was traveling right in here, right? So it traveled right 5, and then x of 1 would be 2 minus 3, plus 2. So 4 minus 3, which